Out in the vast, cold expanse of our cosmic neighborhood, far beyond the rocky inner planets, resides a true celestial marvel. This is Saturn, the sixth planet from our Sun and an undisputed giant. If you could gather all the other planets in the solar system, except for Jupiter, Saturn would still be more massive. It's a gas giant, meaning it doesn't have a solid surface you could stand on. Instead, it's a colossal ball of gas, mostly hydrogen and helium. These are the same basic ingredients that make up the Sun. Its sheer scale is hard to comprehend, but what truly captures our imagination isn't just its size. It's the breathtaking system of rings that encircles it, making it the undeniable jewel of our solar system. Those famous rings look solid from a distance, like a giant cosmic record spinning around the planet. But if you could fly close to them, you would see something entirely different. They are not solid at all. Instead, they are made of countless individual pieces of ice and rock. Most of these pieces are quite small, ranging from the size of a tiny dust particle to chunks as big as a house. All of this material is orbiting Saturn together, creating the illusion of a smooth, continuous band of light. These rings stretch out for over 280,000 kilometers, yet they are shockingly thin, on average only about 10 meters deep. It's like a sheet of paper the size of a football field. Where did these magnificent structures come from? For a long time, we thought they were as old as the planet itself. But we now believe the rings are surprisingly young, perhaps only about 100 million years old. That might sound like a long time, but in the 4.5 billion year history of the solar system, it's just a fleeting moment. The leading theory is that a small icy moon, maybe about 400 kilometers wide, strayed too close to Saturn. The planet's immense gravity acted like a cosmic tidal wave, tearing the moon apart into trillions of icy pieces that then spread out to form the glorious rings we see today. But this cosmic artwork is not permanent. We've discovered that Saturn's rings are disappearing. The very same gravity that created them is now slowly pulling the ring material down into the planet's upper atmosphere. It's a gentle but constant process, a kind of ring rain of icy particles. At the same time, some of Saturn's tiny shepherd moons, which orbit within the rings, act like cosmic vacuum cleaners, absorbing dust and debris. So, we are living in a special time, a privileged moment when we can gaze upon Saturn in its full, ringed glory before it fades away over the next 100 million years or so. If you could plunge beneath the serene-looking cloud tops of Saturn, you would enter a world of unimaginable violence and speed. This placid-looking giant is home to some of the fastest winds in the entire solar system, second only to Neptune. These winds whip through the upper atmosphere at incredible speeds, reaching up to 1,800 kilometers per hour near the equator. That is faster than the speed of sound on Earth. These powerful winds are what create the faint, beautiful bands of color we see on the planet's surface. They are jet streams, similar to the ones on Earth, but on a scale that dwarfs anything we could possibly experience. The most bizarre and captivating feature in Saturn's atmosphere is a storm unlike any other. At the planet's north pole, there is a massive six-sided hurricane known as the hexagon. This perfectly formed geometric storm is wider than the entire Earth. It's a stable, long-lasting weather system, first spotted by the Voyager spacecraft in the 1980s. A powerful jet stream, like a massive atmospheric wall, boxes in the storm and gives it its strange, sharp angles. We still don't know for sure what creates this incredible formation, but one idea is that it's driven by a giant vortex swirling deep within the planet's liquid hydrogen interior. This giant hexagon even changes its color with Saturn's long seasons. A year on Saturn lasts for about 29 Earth years, and its seasons are equally drawn out. When our probes first saw the hexagon up close, it was a deep blue color, which we think was a sign of its polar winter. Years later, as summer approached in Saturn's northern hemisphere, the hexagon had transformed into a golden yellow hue. Scientists believe this color shift is caused by sunlight interacting with particles in the atmosphere, creating a kind of seasonal smog. It's a reminder that even on a distant gas giant, the fundamental rules of chemistry and physics are at play. Saturn itself is a planet of extremes. It is the least dense planet in our solar system. In fact, its average density is less than that of water. If you could find a bathtub big enough, Saturn would float. This is because it's made mostly of the lightest elements, hydrogen and helium. Deep inside the planet, the immense pressure from gravity squeezes the hydrogen gas so hard that it becomes a liquid, creating a vast ocean of liquid metallic hydrogen. At the very center, we believe there is a small rocky core that is incredibly hot, perhaps twice as hot as the surface of the Sun. This internal heat is part of what drives the planet's wild weather. For 13 incredible years, humanity had a robotic emissary exploring the Saturnian system. This was the Cassini spacecraft, a joint mission between NASA and the European and Italian space agencies. Launched in 1997, it embarked on a 7-year journey across the solar system, finally arriving at Saturn in 2004. What Cassini revealed to us completely revolutionized our understanding of this distant world and its many moons. Before Cassini, our best views were from the fleeting flybys of the Voyager probes. But Cassini stayed, orbited and watched, giving us a long-term, front-row seat to the wonders of Saturn. One of Cassini's greatest triumphs was giving us an unprecedented look at the rings. It showed us that they were not flat and uniform, but a dynamic, three-dimensional environment. The probe discovered towering structures within the rings, vertical waves and mountain ranges of debris with peaks reaching up to 200 meters high. It was as if the rings were a miniature mountain range made of ice, constantly shifting and changing. Cassini also helped us understand the role of the shepherd moons, tiny moons that orbit near the rings, their gravity sculpting the edges and carving out the gaps we see, like cosmic artists shaping their masterpiece. Cassini didn't just study the planet and its rings. It also turned its gaze to Saturn's fascinating family of moons. And what it found on one small icy moon named Enceladus was one of the most exciting discoveries in modern space exploration. In 2004, the spacecraft detected something strange happening near the moon that was disrupting local radio waves. Upon closer inspection, Cassini saw gigantic plumes of water vapor and ice crystals erupting from cracks near Enceladus's south pole. These geysers were shooting material hundreds of kilometers out into space, sourced from a liquid water ocean hidden beneath the moon's icy shell. After 13 years of groundbreaking science, the Cassini spacecraft was running low on fuel. Mission scientists knew they couldn't risk it crashing into one of Saturn's potentially habitable moons, like Enceladus, and contaminating it with earthly microbes. So, they planned a daring final act, the grand finale. In 2017, Cassini performed a series of 22 dives, plunging through the unexplored gap between the planet and its innermost rings. On its final orbit, it dove directly into Saturn's atmosphere, sending back data until the very end, before it was vaporized by the heat and pressure, becoming a part of the very world it had studied for so long. The legacy of the Cassini mission is a universe of new questions. Its discovery of a subsurface ocean on Enceladus has made this tiny moon one of the most compelling places in the solar system to search for life beyond Earth. The water erupting from its geysers contains not just water, but also salts and organic molecules, the basic chemical building blocks for life as we know it. The presence of a liquid water ocean, combined with a source of heat from the moon's core, creates an environment that could potentially support life. This makes Enceladus a top priority for future missions that could one day fly through those plumes and analyze them for biosignatures. Cassini also gave us a deeper appreciation for the intricate dance between Saturn and its moons. We learned that Enceladus's geysers are the source of Saturn's largest and faintest ring, a huge diffuse halo of water vapor that trails the moon in its orbit. This discovery connects the geology of a tiny moon to the large-scale structure of the entire Saturnian system. It shows us that planetary systems are not static collections of objects, but are interconnected and dynamic, with moons actively shaping the environment around their parent planet. It's a cosmic ecosystem, and we've only just begun to understand its complex relationships. The knowledge that Saturn's iconic rings are temporary adds a sense of urgency and wonder to our study of the planet. We are living in a privileged time, able to witness a planetary feature that may be relatively rare in the universe and is destined to disappear. Understanding how the rings formed and how they are now dissipating helps us piece together the history of our solar system and the chaotic processes that shape planetary systems everywhere. The final images from Cassini will be our last close-up views of Saturn for a long time, making its data a precious resource for generations of scientists to come. Ultimately, Saturn is more than just a beautiful object in the night sky. It's a natural laboratory for understanding how planets form and evolve. It teaches us about the extreme weather, about the physics of rings, and about the potential for life to exist in unexpected places. The mysteries of its hexagonal storm, the secrets hidden in its deep interior, and the tantalizing prospect of a life-bearing ocean on Enceladus ensure that Saturn will continue to be a source of inspiration and scientific curiosity. It beckons us to return, to explore further, and to continue unraveling the secrets of this majestic gas giant.